All right, ladies, so we went through in class how to do the inverse by hand, but I thought I would just create a video just in case you were a little bit confused and wanted to listen to it again. So I've got the same sheet here that we had before. I'm just going straight to what I highlighted because sometimes a lot of information can overwhelm you when all you need to know is a little bit. So I thought I'll keep on the screen what you need to know. So remember, the inverse is represented by to the power of -1. And when you're taking the matrix by hand, first of all, identify your matrix elements A, B, C, and D. And this is only for a 2x2 matrix. You don't have to do any other matrix inverse by hand, just a 2x2 matrix. All right, so once you've identified the A, B, C, and D, you're just substituting them into this formula. Okay, so it's 1 over AD minus BC multiplied by the matrix D, -B, -C, A. So I'll do an example again to show you. Also, it's important that you know what the determinant is. So you can see the determinant is just this denominator, AD minus BC. And the determinant just tells us whether you can take the inverse or not. So if this was 0, okay, you can't take the inverse. So, and that's simply because we can't do 1 over 0. And your calculator will also tell you whether the determinant is 0 or not. But if you try to do the inverse, it will also tell you whether you can do if you can't do the inverse. So it'll either do the inverse for you or it will say it's undefined. So basically, if the determinant is 0, the inverse matrix does not exist. Okay, but that's more probably going down the path of matrices in methods and specialist. So we just need to know, all right, how do you find the inverse by hand? Often the determinant is not 0, so it is a number, so you can take the inverse, but just so you know, it can be 0 as well. All right, so let's do an example. So there is an example that we did in class, but I'm going to do a different one. The good thing about matrices is I can use any numbers I like. Sometimes they don't turn out to be very nice numbers, but I don't have to think too much about whether they're actually going to work. So I'm going to call this matrix A, and let me label this 2, 4, let's do this -1, 3. Okay, and I've just made up those numbers, so they can be any 4 numbers. And remember, oops, there should be an equal sign there. We're going to take the inverse of a 2x2. So we label it A, B, C, D. And it's important that you go across like that. So this is A, this is B, this is C, and this is D. All right, so when we're taking the inverse, we have a formula. So it's 1 over AD minus BC. And then we multiply that. We switch the A and the D. And then your B and your C, the numbers stay, but you're just multiplying it by a negative. So if it was already a negative, it becomes a positive. And if it's a positive, it becomes a negative. All right, so now we just substitute these numbers in. So A is 2, D is 3, B is 4, and C is -1. And I'm going to put brackets around that because we're dealing with a negative, and sometimes we can get negatives mixed up. All right, so we're going to just switch our D and A. So D is now 3, A is 2. And B is positive, so now it becomes a negative, so -4. And C is already a negative, so it becomes a positive. All right, so let's just tidy that up because the denominator, we don't want to leave it like that. So we've got 1 over 2 times 3 is 6. 4 times -1 is -4. So it's going to be minus -4. So 2 negatives gives you a positive. And then we've got 3 Sorry, I was jumping ahead. I knew you were going to come up. Don't like that. Okay, sorry, that was my fault. So I was doing 6 plus 4. So 4 times -1, and that negative gives you 6 plus 4. I wrote 10 because in my head I was doing 6 plus 4. Okay, so we've got 1 over 10, and there's our matrix. Okay, so you can leave the inverse like that. Your determinant, remember, is just the denominator, so in this case it's 10. But it's a good idea to do the scalar multiplication. Sometimes this works really nice for me, and other times it just does not cooperate. So remember, when we're doing a scalar multiplication, it's 1/10 times 3 in that first. So everything inside just gets taken over 10. And remember, you should simplify. We've got some fractions in there that can be simplified. 3 over 10 can't be. -4 over 10 becomes -2 over 5. 1 over 10 is already simplified, and then 2 over 10 becomes 1 over 5. And you also might have these as decimals, so just be aware you might have to put, and I can easily do these as decimals, but if you're using your calculator, just make sure you can go from fractions to decimals. So I might show you in a sec how to do that. Okay, and there it is. So it's in fraction form or decimal form. It's probably better to have it in fraction form if it's an irrational number, but if it can be simplified easily to decimals, then you can leave it as decimals. All right, so I'm going to show you on the calculator. I'm just going to come up and get my original question. What was it? 2, 4, -1, 3. Let's start anew. Okay, so, and I've already forgotten it. So 2, 4, -1, 3. 2, 4, -1, 3. So you can take it to the power of -1, and there it is. Now, mine's in fraction form because of my settings in my calculator, and I'll show you how to change that in a second. If you want to convert to decimals, you just go Control Enter, and it will put it in decimals for you. Now, if you want to have it in fractions and it's giving you decimals, you just go to Menu. No, you don't, sorry. You go to Doc, Settings, Document Settings, and I've got it in Auto. So Auto or Exact will put it in fraction form. Exact will do it all the time. And Approximate, if you've got it in Approximate, it's probably why it's putting it in decimals. So I'm just going to leave it as Auto. Now, the other thing, determinant. Okay, so we just write DET, and, oops, God, that's me doing something with that. I think I need glasses. I was always so proud that I had good eyesight. And it's slowly going. All right, and there's your determinant, which is 10. Okay? All right, bye girls.